Hi, my name is Noah Tajudeen, and I'm from Woodson High School. This is my project entitled Reef-Safe Sunscreens, the most moisturizing consistency of non-nano zinc oxide sunscreen. This is a continuation project of one I conducted in 2021, entitled Repel Those Rays and Rescue the Reefs. For some background, sunscreen is a cosmetic product that protects skin from harmful ultraviolet radiation, the most damaging band of sunlight to human skin. Sunscreens, though a luxury, are necessary to protect skin from potential diseases like skin cancer that result from everyday sun exposure. Active ingredients found in sunscreens are either chemical, like oxybenzone, or mineral, most commonly zinc oxide. I will delve into sunscreen's effect on coral reefs, but know that a reef-safe sunscreen uses mineral active ingredients in less than or equal to 25% concentration with non-nanoparticles, all denoted on a label or in ingredient lists. My prior research established that reef-safe sunscreens work just as well, if not better, than their reef-toxic counterparts, which is important for consumers to consider as they proceed through my research persuading the use of these reef-safe sunscreens. But how did I determine this conclusion that I just mentioned? In short, I used a UV lamp and UV index detector, painted reef-toxic and reef-safe sunscreens on saran wrap, and compared UV index reduction between the two different types of sunscreens after I put the saran wrap between the lamp and detector. I concluded that, when compared at the same SPF levels, reef-safe sunscreens reduce the UV index measurement by an equal amount as reef-toxic sunscreens. I also experimented with a rash guard t-shirt, but just for the sake of awareness, I have since concluded that rash guard t-shirts wash off microplastics into the ocean, so it's better to wear a cotton t-shirt for sun protection. Discussions of wearing reef-safe sunscreens are incredibly important because chemical reef-toxic sunscreens contribute to the bleaching of coral reefs, which are currently in their third ever major coral reef bleaching event. The UNEP even predicts that most of the coral reefs will be dead by 2050. This happens when sunscreens wash off into the ocean from beach going or daily wear and do all of the following: get into porous coral reefs and constrict them, react to form hydrogen peroxide that kills phytoplankton, kill algae that gives coral reef their color, and finally damage the DNA of coral reefs. This is important when considering that a very small amount of sunscreen is needed, about 1 drop per 6 Olympic-sized swimming pools, to start these aforementioned effects. This means that there is a grave risk to coral reefs and all of their associated services to humans and the environment posed by wearing sunscreens. This brings me into my research question for the project. What is the most moisturizing consistency or texture of reef-safe sunscreen? Clay, spray, or lotion? Though moisturization is a secondary benefit of sunscreens, answering this question, I believe, will help consumers make a more confident decision to buy reef-safe sunscreens, knowing which suits their skin needs. First, I must state that to moisturize is to retain water or moisture, which is done through our cosmetic products' oils, which lock moisture in, and humectants, which draw moisture from the air. They are vital to prevent the epidemic of dry skin caused by a variety of environmental and genetic factors. To give an overview of my procedure, I painted each sunscreen onto agar plates and measured the mass change over 4 days. The mass that was lost in each was the evaporation that took place, which signified how much the sunscreen was able to retain moisture. I compared these moisture retentions by taking the percent mass change on each day for each trial, averaging these values and graphing them. I hypothesized that the clay would be the most moisturizing, then the lotion, then the spray. Shown here are my raw data, as well as what the percent change in mass was over the 4 days in graph format, and finally I included a picture of what the agar plates looked like. So we can tell from the graphs and data tables that the actual order of most least moisturizing was lotion to clay to spray. The lotion sunscreen steadily prevented moisture loss over the 4 days in total. The clay sunscreen much more quickly reached a point at which no more moisture was lost, and as did the spray. Standard error revealed that there was no significant difference between the clay and spray sunscreens in their percent mass loss each day. These results contradicted the hypothesis. The reasoning for each being predicted as they were was based on thickness of application, but in retrospect, lotions are known for containing those occlusives and humectants that moisturize, so it being the most effective by far, neither comes as a surprise. The limitations listed here for this experiment fall under the general category that it is often difficult to mimic the nuances of skin's behavior as a bodily organ with an experimental design such as mine. 2 sources of error were that one of my petri dishes broke, so my control group was missing an IV, and the digital balance that I used had slight inaccuracies to the 1,000th place. Beyond the obvious conclusions I made, I can now synthesize my past research and current. I made a chart to illustrate this, and here is one example. A consumer with dry and tan skin may require a lotion Reef-Safe sunscreen, for it offers high moisturization with that medium level UV protection. Overall, my results effectively increase consumer awareness of Reef-Safe sunscreens. Now knowing how necessary they are for coral reef preservation as well as how they can treat different skin types, consumers can, as I showed, make the informed and motivated decision to go reef-safe. In the future, I would like to test more consistencies like balm, powder, and oil to increase the options for consumers. I also realized that a lot of the time, science research relies on advocacy, and for this project, I would love to share my findings with organizations like the EPA or FDA to spread the word. Ultimately, this is in the effort to repel those rays and rescue the reefs. Here are my sources, and I thank you so much for listening.